So risk assessment.
Yeah.
Did he talk about that in class?
Yeah,
Yes.
He went over chapter 3 of the radiation protection book that he wrote.
This book.
No,
Did he
No,
give you?
he gives the chapter.
Yeah,
Biological effects of radiation.
You just have that on you?
Yeah.
Remember we did this in 495, but we didn't do it. I don't remember. Maybe we did it in this one.
We only spent like a week on it.
Okay.
Very good.
Probably the tables are all towards the back. Third.
Slash table is
All the tables.
So, yeah, I think this is going to be the same information that's in the.
Yeah, there's more info in this chapter than there is in the 495 book.
There is.
Yeah.
Well, the
Did you
big.
read this part?
I'll give you guys just an example from.
Actually, the tables are confusing. It seems that it's the same table for each one.
Yeah, a lot of the tables are extremely similar.
Yeah.
It's hard to decide which one
yeah,
to use.
and
Yeah, it
it's,
has really-
it's hard to decide really.
Really easy to understand
I don't
tables
know.
in here.
I'm guessing, I just graded the 495 homework over this. Table 913 in the 495 book is probably what you're going to want to use, and 910 if you have the 495 book with you.
How do we
So-
decide which table to use though? Because a lot of the time there will be 2 or 3 tables that are over essentially the same thing,
Mm-hmm.
but one's listed from a different year, or one's listed for a slightly larger group.
Yeah, that's
Just-
the problem I have is just, like, of all these tables in this chapter, which one do I use?
Which one do we use? Because a
Are
lot
there
of the
ones
time,
that are very similar. Okay, let me.
well, even in the 495 book, there are 2 or 3 tables that are studying the exact same thing, but they have completely different values.
They're also slightly different tables. They do have slightly different meanings. So let's say we have a worker who has an accident, and the worker receives 1, or let's say half of a gray, and this is a high dose rate. Let's say the worker receives half of a gray really quick, just had an accident at work. So, and let's say we want to find what is the, how much more likely is he to get cancer?
So this is just to contract cancer, not to die from cancer?
Sure. So you would look for a table that said excess cancer incidence. And there's one here, in this 495 book, 913. There's probably a similar one in that book. Is there one in there? There's probably one similar in that book that has something like that. So table 913 has excess cancer incidence and mortality per 100,000 males and 100,000 females for 3 different types of scenarios. So this one has one of the categories is a single exposure. To 0.1 gray. This isn't going to be exactly based off of this, but it's going to give us some ballpark value.
There are 2 more cases in this table, right?
Mhm.
What's the difference between both of them?
Okay, so they also have continuous lifetime exposure of 1 milligray per year. And there's also a continuous lifetime of 1 rad per year. from ages 18 to 65, so like a working life. Big difference between this one and these two. This is a high dose rate. High rate of exposure. These are low dose rates. Does that make sense? Like you're getting this all of a sudden,
Okay.
and your body may have a hard time recovering from that single dose of radiation that quickly. Whereas these, you're receiving a much smaller dose on a daily basis, so your body has time to heal over the year.
So
It
the
has
1
time to repair
milli
that
through the
damage.
ear.
What's that?
The 1 milli gray through
Yeah.
the ear.
Mm-hmm.
Okay.
So this is a lot smaller. I'm not. I would have a hard time telling you the difference between the last two.
Yeah, I'm asking the difference between number 2 and number 3.
Number 1, number 3.
No, 2 and 3.
No, number two, number three.
The last two cases, because if it's only based on this is 1 milli gray and the other 1 red, so we can use.
This is going to be 10 milligray. This is equal to 10 milligray per year.
10. Okay. So this is the only difference. This is 1 milli and this is 10
Yeah,
milli.
but this is also you're gonna start receiving this after age 18. So this is probably data taken from people who work at reactors or people who work at places that have a slightly elevated background or radiation levels. So whereas this may be from people who live in an environment from the time they were born until the time they die that is at a higher rate of radiation. I mean, different places in the world will have different levels of radiation in the background. So maybe that's the difference. I'm not positive, but that might be a difference. But this is specifically targeted for working life. For you're working there your entire life, from 18 to 65. Okay.
Okay.
Anybody have questions about this, or want me to go through one?
If you don't have the 495 book, it looks like table 314 on page 156 of the chapter that he gave us.
Yeah,
It's the same thing.
314 on page 156.
Yeah.
314.
I'm trying to, like, what's the difference between these two tables?
Well, that's a lifetime cancer risk estimate for low LAT radiation, and
Oh,
this,
so that's for one person?
and this is, no, it's, I mean, it's
For-
normalized to 100,000 persons, but that's just lifetime risks, whereas 314 has the single exposure
Yeah.
calculations as well.
Okay, so.
That's the biggest difference, is single exposure to
Alright,
lifetime
so
risk.
313 is
For a high dose rate.
for a low dose rate.
It's just like-
313.
Okay, I don't have it in front of me, so
Yeah.
the single exposure is gonna be a high dose rate.
And you're gonna have to do a ratio, cause it's normalized to 0.1 gray and we use 0.5 gray, so you'd have to
Yeah, you just
have
say
to
it's
take a
about 5
ratio.
times more.
Yeah.
There's not a lot of data on this, so we
Right.
can't be positive on all this, so. If you have a problem with this in a test, write out, like,
All your
words,
units.
what you're doing.
Yeah.
Otherwise,
Assumptions,
he's not gonna have any idea what you're
yeah.
doing.
What
It-
table you used, why you use that table.
Yeah.
Alright, so can we work through this problem just as a group then?
Which
Where you
problem?
have,
This
I'm gonna
one?
read it.
Okay, okay.
Okay, so you have 1 million